Okay, ready? Okay, in this lesson, what we're going to do, we try to use options in SolidWorks simulation that the mesh and elements is important when you do simulations. And if you have a different mesh or final mesh or cross mesh, that will provide you a different result and that show you a different of accuracy. So in SolidWorks, we have another functions which is to help you to find the convergence of elements that you will get the result close to something or approach to the accurate result or makes the error less than what you want. For example, if you want an error less than 2% or 1%, you can set on the SolidWorks to find your convergence of element. Okay, in this one, it's a blanket that we have in this shape, and we can do just only half. So in the configurations, we have a default configurations and symmetry that will just show you just half of the blanket. Okay, and that makes your computational cost is lesser. And number of elements, number of degree of freedom will be less. And that will help you run your programs faster. Okay, go to create the new study and in static as well. And I would like to change the name. Copy. I want to rename. Let's say this one is standard. Okay. The standard one. So we will apply load and fix geometry. Okay. Let's say the material first. The material is already set for AISI 304. And on this one, we don't have any assembly. We don't need to create the connections, no contact set. And on the feature, we just set fixed geometry. And I select the surface on the back to be fixed geometry. And that's just click OK. And make sure that you, let's say, this surface and this surface is symmetry, because now we just cut it in half. So we have to define that is a symmetry plane. So we go to the feature and remember advanced feature. And let's say it's symmetry. Make sure you select two surfaces. Okay, that would be the symmetry plane. That's it. That's all the constraints, the restraint that we set on the surface. And then I need to apply the force. And the force we apply on this ring, half ring here, as 11,000. Just a force, 11,000 Newton. Okay, and then we will create a mesh. Let's say just a global mesh. The curvature base. So for the standard mesh, they will just have the same elements, same size, or maybe mostly same size. And for the curvature, they will change the mesh a little bit to capture with the curve. That will be better, slightly better. So we choose the curvature base and then click OK. And that you have the mesh generate here. Okay, and then just run. That's just an easy case that we have done for a long time before. And what we have here, that is the longest stress, about 214. And then I'd like you to copy the study. Copy the study. Yeah, and let's say the name to be edge adaptive. Edge adaptive. The configurations, we use the symmetry one because we just calculate just half. Okay, edge adaptive. And then okay. On edge adaptive here, on the module 3, you click right and go for properties. And you will see the tab. What should I show you? Adaptive here. And the default is say none. Now we can change to edge adaptive. And actually we have P adaptive as well. What the difference? For edge adaptive, you see the target accuracy. So we need about 98% target accuracy. So in edge adaptive, the software will regenerate image for you just in the point that the things is important area. And it's have found that it's the highest stress or highest deformations, the software will try to remage on that point by using edge adaptive option. And the accuracy is about 98%. That means they will rechange the image until they get the result close to something. And that the difference is not much, just 2% different only. And then they stop remaging. And then for the accuracy bias, if you get it like too slow, it will be remaged quite fine. That will take your cost slow, your time computation. And this one is a maximum number of loop. So it will take two choices. If it is at the target accuracy first, they will stop, even if just 2 loops. Or another way, it will stop just for 3 loops only, just remage 3 times. And that you will get the result better on each time. So on this one, let's say to do 5 loops. And then okay. And the mesh, we use the same. And that will just ask you to delete all one. Yeah, just mesh, the same curvature, and I didn't change anything. And that will be the default mesh. And when you click run, you see the program run 2 times and 3 times until they get, you say the target is already 98.19% that they stop, not done 5 loops. Only 3 loops, you get the result, and the result of only stress going to 279. But the only one that we have done is 214, right? Yeah, 214. That's different. Let's see the mesh. How different? So remember, go to the setting and then the model, go mesh. That will be your final mesh. That program just remesh for you to get a better result. Okay. And then if you click right on the result, you can just say define adaptive convergent graph for you and show the warming stress that you have the convergent graph. What does it tell you? Say for the default of elements you have, start at loop number 0. And you will get the stress about 214. And then another loops, they're done on the first loop there, and the result they get is about 200, let's say 27. Okay, because it's about that. And the difference between this point and this point is error more than 2%. They don't stop. They go further for the second loop until they get this result to 229. And the difference between 229 and 277 is less than 2%. That's why they stop. Okay, and that you will get that result there. And if you run more than 3 loops, you will see the result that will be close to 229. That's why it stopped. That's the convergence of the mesh or the number of elements. Okay, another one, let's say copy study again. And H adaptive, number 2. If we change the property of H adaptive to be like a 99%, let's see the convergent graph. Let's say 99%, and then we mesh the same. Delete the old one, yes. And mesh the same. Did you change anything? Just cover your base. And just run. 1, 2, 3, 4, 5 loops. Because they have 2 options, they stop when they get the target accuracy at 99% or 5 loops. They stop at 5 loops. And let's see the convergent graph of warming stress. Here. You see, the graph is converged to a number that will be accuracy result. That will be about 229. That would be a better result from mesh. Okay. And then if you keep right on the property again and H adaptive, and let's click on the mesh crossing here. Mesh crossing here. So before we click on this, let's go back to here. You remember the mesh on here, and that when we change that, you will know the difference. Property and click on mesh crossing. Okay. And then run. Or maybe we have to delete the old result first by do mesh again. So I have to delete first. Otherwise, they will remember the old result. By mesh, create mesh again and delete the old one. Yeah, and just create the standard curvature base. And then let's check that I already click on mesh crossing. and then front. 1, 2, 3, 4, and 5. Stop at 5 loop. And then what the difference? If you notice that, so some of the area here doesn't get refinement. No refinement on this part, you see? So if you have a maze processing, they will just refine the mesh on some particular point. So some of the other area which is doesn't have anything changed, they will not do refine mesh. That's the options. And that will make, if you show the mesh detail, yeah, there will be difference between mesh processing or doesn't have mesh processing. Okay, the last one, P adaptive. So I will copy from this study, and let's say is P adaptive. Okay, P adaptive. Just keep right on the name of the study and say property, change the adaptive to be P adaptive. For P adaptive, they have the dialog box to control under the H adaptive. And the conditions of P adaptive, the calculations will stop when the total strength energy it changes about 1% or less than. So in this one, we can take another options, which is we have a root mean square and a root mean square of a displacement, a root mean square for the volume stress, and we have the total strain energy. So let's say total strain energy. And for the percent, let's say it's less than, let me check, I think it's 0.05. Okay, change to be 0.05. That would be a very small one to let them stop. Okay, for P adaptive, you have a starting P order, which is mean. Remember, before we start the static study, we set on simulations and mesh, which is high quality. If we don't take the high quality, we will take the, let's just click on that to show you simulation option and default mesh. You see, we take a high quality. And if you don't take the high quality, we take the DAF mesh. So on CAE that we calculate by hand, we use an element which is a linear element. Remember? Linear elements have only 2 nodes on each endpoint, and the relation between 2 nodes will be linear. And that means draft quality of mesh. And then you take a high quality of mesh. That means you will have high order of elements. It's not just linear equation, and that will be polynomial equations, which is order 2, second order on high quality. It means in 2 nodes, you have another node in the middle in 1 element, 3 nodes in 1 element, and that will make the shape like a curve, like a parabolic. That is a polynomial equation, that high quality mesh. And then in P adaptive, you can start from second order. That means number 2 that for P order starting. And the maximum of order, we can take 5. That's the limitations of the software. We can use just 5 order of polynomial equation. And that means if you have one element of beam, you will have 6 nodes in one element. That would be 2 find, and that would just make the curve on that change or deformation. Okay, let's just do that. But the program will change for us. They will start at second order and change to the third, fourth, and 5, and then they stop. Sometimes they stop before because we just say the accuracy of the strength energy just less than 0.05, and then they can stop if they reach that result. Okay, and the loop just at 4. Okay, and then do the mesh, just the default of curvature. Yeah, that's the default starting with the same element, and then we run. The element will not change, just the equations of element change. Loop 3, loop 4. You see? This will have only 4 loops, and the element doesn't change, but the equations of element change to the order, higher order. And we get the result of 227 even without change mesh. Okay, and if you just show the convergent graph of the bond stress as well, you get this. Similar to edge adaptive, when we done the first edge adaptive, right? But the edge adaptive had to change the mesh. But this one doesn't have to change the mesh, just change the equations of mesh to get the same result. And even if we get more loops, yeah, it's close to 229. Okay, that's it. I think it's that all of the course that I can just provide it for you. And hopefully that you try to apply the knowledge and this skill into your project. Even the master projects, I mean the senior project, and also apply on the projects of this course too. On Monday is a public holiday, so you will have time to just taking and talking about your project with your friends in the group. Okay, and just prepare for the presentations and ready to present on Wednesday. We will have presentations in this class. Okay, and we have how many groups? 8 or 9 or 10? Yeah, about 8 or 9. And that I will just, all of the group have only 10 minutes to present. And I already told you what I expect to see. Okay, the convergent one is one of the content that you have to show, because that will just show the appropriate mesh that you've taken. Okay, and that will just provide the result which is high quality and high accuracy. That's what we expected. And you have to compare. It's not just you just show me one and you say this is the best. No, it is impossible. Okay, I don't believe you. Make sure that you have evidence and everything to confirm what you have done is the best choice. It's the best way and it's the best result. Okay, so that's it for me. Thank you very much, and hope that you will, pass all of the courses this term. And some of you have a co-op next term. So good luck on your way and see you again. And of course, we will see you on Wednesday for the project presentations. Okay, have a good lunch.